The site of this green home in Long Island, New York, is host to a variety of seasonal climates. Throughout the year, the structure is exposed to weather conditions that can adversely affect the sustainability of the home and the comfort of the occupants within. Through a series of design innovations, architect Anthony Musso has created a system that can not only repel the elements, but utilize them to the benefit of the structure.
Our green home project is advanced quite well right now. We're into the exterior claddings of the project, and the cladding material, brick, stone, slate roof, all come together as a sustainable product.
The slate roof, which has an average lifespan of 100 years, provides ideal protection from water and moisture. The ice and water shield used on the roof structure serves as a moisture and water barrier, protecting the roof from ice damming in the winter.
In the wintertime, there's snow buildup or even ice on the roof. It may have a tendency to creep under the shingle and penetrate the structure. By the ice and water shield material, it's a very water-resistant material that keeps any water or ice from penetrating the structure.
A drip edge around the roof diverts water and ice from entering the structure below, while the moisture-resistant ThermaSteel wall system provides a drainage plane for accumulating moisture.
If by chance water does find its way into the wall membrane itself, being the ThermaSteel, is a rain screen. It's a very high perm rated material, which means that the material itself will not allow water to penetrate. And if the water does hit that, it just drains down, and at the bottom of the wall there are weep holes that allow water to escape out of the wall assembly.
The flow of outside air is another element that is precisely controlled through the meticulous construction of our green home. Traditional framing allows air leakage between components of the foundation, which can hasten the amount of decay and damage to building materials. A foam padding under the sill plate fills in air gaps, as well as the sealing and caulking of all joints of the wall panels.
A building is very dynamic. It's affected by outside conditions, inside conditions. All the elements of the building are actually moving. It's almost like a balloon. If you put a warm balloon outside, it will shrink. If you put it because of the outside temperatures controlling that. Same thing with the building. The outside and the inside temperatures will make those walls and roof and floor systems have a energy transfer.
As a main point of entry for outside air, exterior doors and window frames are preserved through the use of a sealing tape covering the barrier between the window jamb and the wall construction. Penetration of the building's thermal barrier by piping and ducts is sealed by caulking or tape to hasten the airflow through the joints. A building with this degree of control requires a positive fresh air supply at all times.
Because the building is as tight as it is, it requires a certain amount of fresh air coming into it. This is done through an energy recovery system.
At the heart of the building's HVAC system is an energy recovery system used to exhaust stale air from the kitchens and bathrooms while filtering in outside air. Air that passes through the energy recovery system is tempered to the liking of the inhabitants. It can be warmed in the winter or cooled and dehumidified in the summer.
The idea is to control the amount of air that's coming in and where the air comes from. If the building is loosely built and air sealing is not done, air can come, or moisture can come in through various parts of the building that is unwanted, which can cause mildew and contaminated air coming into the building. Through the the energy recovery system, it's filtered air coming in, and it produces a very high quality of environmental air for the building.
The energy load required by the system is calculated using the industry standard manual J design tool, a method which takes into account a variety of energy factors concerning the home and its occupants.
The building itself, because it's so energy efficient, a standard system or the rule of thumb system for designing the heating and air conditioning system doesn't work. The manual J system, which is the industry standard, takes into consideration all the aspects of heat loss and heat gain of a building through the exterior envelope, the interior spaces with the lighting, appliances, people, and a very positive calculation comes out of it, which in most cases is not a rule of thumb calculation, but a very specific number. So a system can be designed to be very, very energy efficient.
The industry standard manual D design tool is in turn applied to the ductwork, going beyond the measurements of each room and employing a diverse set of criteria in determining the needs of the HVAC system.
It's very important to have the air supplied to the spaces designed properly, so it's not air is not overly supplied to an area, but just the right amount of air is provided into the spaces.
All of the ductwork is individually insulated, with each connecting joint sealed together using mastic. This allows for an even more precise delivery of air throughout the system. These measures create a healthy, comfortable living environment that successfully channels the elements surrounding it. These are just a few of the features that set apart this remarkable green home.